Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Developers like to abstract things. Understatement of the year. Abstraction gives us a lot of benefit, but there are times when we need to rein in our enthusiasm for it. It's past time we discussed when abstractions are not useful or are actively harmful. Those are Will's words there in the intro there. I think he wants to talk about this. In this episode, we're going to compare and contrast cases when abstraction is useful and when it is not. So, Will, what's been abstracting you lately?
Man, I've got this head cold. Of course, we recorded yesterday and we're doubling up this week. And I spent most of the morning back in bed, got a little bit of Russian homework done, and then was like, you know what? I don't feel good. I was planning on taking the day off from work anyway. And so I had it scheduled as just time off. But it ended up being a sick day. So about, 8:15, 8:30 this morning, I took some more NyQuil and I went back to bed. Wanted to just sleep. Slept till almost 1. And I'm still definitely not anywhere close to 100%, but I'm better than I was when I woke up. So,
yeah.
How about you?
Well, the art show that we had scheduled last week got postponed, which was good because I had COVID. So, yeah, that wasn't fun. So it was a good thing that got postponed. But anyway, I've been working on basically a couple of things that I had planned on working on for that. And then I had a couple of more ideas come up that I'd like to work on. So, yeah. So I've been doing a lot of art, painting. I got some photography stuff I'm doing. I've got some people coming over this weekend to do a photo shoot, so I'll be able to use those photos as well. Hopefully, I can get them printed in time. Yeah, so that's cool. Also, I got a KVM. Finally, I've been talking about it for a while. Got that one that I was telling you about, Will. But yeah, reworked my desk, so it's a bit cleaner. Not at the moment because I've got, cans and stuff set up for pre-opened cans of bubbly. I like that better than LaCroix. I don't know. It has more flavor. Yeah.
Check that out then. Not that the set of things that has more flavor than LaCroix is pretty much the universal set, but
but yeah, it's got a little bit more flavor than LaCroix and generally is a little bit cheaper. Yeah. That, and I've got this really cool oatmeal stout non-alcoholic beer that I'm sipping on right now.
Nice.
Only like 90 calories for it, so cool. But anyway, yeah, no, I got that sort of reorganized my desk with the KVM. It's actually a bit sleeker. I like it better this way. But because of that, I had to move stuff around in the office, and so my office is a bit of a mess. I need to work on that, especially before they come over for the photo shoot, because I think we're going to do some of the photos in here with my we're doing kind of a punk rock theme, so with my music stuff behind us. But yeah, it's going to be cool. I'm looking forward to it. So, and then really excited about the art show, working on like what I'm going to take, what I'm not, that sort of stuff, figuring out, all right, this is a good piece to display. This isn't. Plus, I'm also doing one of the activities, so working on planning that out and stuff too. So that's going to be fun.
Saving money is hard, especially when you're not sure if you've got the Rona.
True dat, yo.
Yeah.
True dat,
Since
yo.
I'm not sure at the moment.
Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado. And just like us here at Complete Developer Podcast, he focuses on helping you not only establish a real plan, but taking action so that you can live your best life.
Investing in financial planning services really comes down to whether or not you can actually improve your finances. And with the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Yeah, Level Up has a unique pricing model that will help you no matter where you are in your financial journey. So, whether you're a junior developer just starting out or a weathered senior developer looking forward to retirement, Lucas can help you.
Lucas is also a fiduciary for his clients, which means that he's not here to sell you a service or a product, but to help guide you to a better financial situation.
No. So, guys, you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics you probably face and interviews other IT professionals who share how they navigated their careers. You can also learn a lot more at his website, levelupfinancialplanning.com.
We all like abstractions. We use them every day to make sense of the world. Sometimes those abstractions can be pretty useful. Like saying, hey, if we have interchangeable parts, our factories are more efficient, right? That's a way of kind of creating an abstraction in the physical world. However, we also have to be careful because history is littered with bad abstractions and just so stories to explain the world that led to horrible things. Many other abstractions just lead to dead ends and mediocrity, though. In technology, everything sits on a pile of abstractions, whether you're talking about the application server level or you're writing assembler code to work directly with a processor. We either stand on the shoulders of giants or we don't get to stand at all.
And therein lies the problem. Because we all rather quickly recognize the value of abstraction, we all have a pretty strong bias toward building them. While this instinct can be useful, it really needs to be moderated to some degree by careful thought, as not every abstraction is reasonable, especially once you stack them together. We often hear about the perils of premature optimization and how wasteful and destructive it can really be. But people often miss out on how abstraction is a subset of optimization. Like in this case, abstraction is an optimization of the time and attention it takes to get something done in code.
If you've been around the block a few times, you probably have worked on at least one code base where someone got a little happy with abstracting things. If you've been around the block a few times and you don't remember this problem, you probably were the source, though. Nevertheless, bad abstractions can double or triple the amount of time that is required for even simple tasks, and can also foster disagreements among staff members, especially if the person who wrote the abstraction is still there and still proud of it. Bad abstractions are like personality defects in that they also accumulate piles of other abstractions to deal with. And that's really the thing that we're going to kind of aim at here is it's not just that abstractions that are bad, but that you tend to create other bad abstractions to deal with them.
Yeah, and it's always better to be the person who created the bad abstraction than the person who has to fix the bad abstraction. So, I say it's always better. It's, easier doesn't mean better. So, guys, in this episode, we're going to discuss a few circumstances where you might be tempted to employ an abstraction. In some cases, this is correct. However, the situations we're discussing are situations that are highly likely to produce abstractions that can cause more problems than they actually fix. We'll give examples where we can, but some of these things are a bit challenging to understand until you've seen them actually in the code in the wild blue yonder.
Yeah. So the first one, and this is probably the bane of everybody's existence as far as abstractions go, and that is abstracting for what we're going to need or what we think we're going to need.
Oh, yeah.
Yeah. Predicting the future is really hard. It's a lot harder than you think. And honestly, if you were that good at it, you'd own the tech company rather than working there.
Yeah. Say, for example, you're building a tool for pulling content from Twitter. Do you abstract immediately because you think you'll do the same soon for Instagram, TikTok, Facebook, YouTube?
Right. Yeah. And that would be a premature abstraction. Those sites all have different types of content, different rules around that content, different ways of retrieving it, and they have fairly disparate APIs. And you don't even know if you're going to need it in the first place.
Yeah, that's interesting. I had a similar conversation to this just this morning. Not about pulling from social media. That really wouldn't make a lot of sense in my job. A little bit, but not a lot. But about we're trying something out that's gonna I think is really gonna help our QA team. And so I just I suggested basically that we set up the way we set it up is so that other teams can do this in the future for their QA. And it's that's a little bit of an abstraction early on, but I'm also thinking it's not actually going to negatively affect like we looked at it and like setting it up this way is not going to negatively affect what
Right.
we're doing now.
Well, and I think there's something to be said for processes, making them repeatable. Like that's not an abstraction. That's just good documentation
This wasn't that it was actually it was an abstraction. I'm just being vague on purpose as to what we actually did. So
gotcha. But going back to the social media example, if you start out with an abstraction, you're going to make your Twitter integration harder, right? And you either spend a lot of time in design or your design has to be reworked when you add one of the others. And the reason I just talk about this situation is that this is a boneheaded mistake I made quite a few years ago because I tried to do that where it's like, oh yeah, it can pull from Twitter, it can pull from Facebook, it can pull from, I'm trying to remember where else it was capable of pulling from. But basically I made this really, really complex interface for doing that. And then made a bunch of implementers for it. It's like, but you made the complex interface with Twitter. And so the Twitter piece didn't perform well and was really brittle. And then when we added something else to it, it just was not workable at all. We had to rip all that out. That's pretty embarrassing when you spent a good chunk of the weekend on it,
Yeah. Yeah, I can see that being embarrassing and very frustrating when you get in there and do that. I like the personal experience there though. That's a good one. So next is abstracting for similar things that have a high chance of later divergence. So this one kind of comes down to predicting the future as well. However, this time you have two disparate but fairly similar systems that you're trying to combine. And I've seen this too, where early on it looks like, oh, hey, we're building the same thing, so we'll just do it together. Whereas if they had looked at, like, this was a junior mistake that a fellow junior developer of mine made. If they had just looked at other systems, like other apps similar within the environment, they would have gone, oh, no, those are going to be very different eventually.
Right.
But right now, like what we're doing is, yes, it is similar, but yeah. And then like the hackiness to make it fit.
Yeah. So we'll give an example here. Let's say that you're making a library for interacting with digital assets that you've stored, and you currently support file system storage, S3, Azure Blob storage, and storage in a SQL Server database. You might be tempted to abstract this and just go, hey, we just have a different driver for each one, because the code using those assets doesn't really care where they come from, right? But this would actually be a pretty incorrect abstraction. The means of retrieving these assets is going to vary, right? Like SQL Server, you're making a socket connection. S3, it's HTTP. The file system is the file system. So there's a lot of things going on there. For instance, you also have a different security landscape that's going to jump out at you. So S3 is going to be different than SQL. And both SQL and your local file system can run out of space. Theoretically, S3 can too, but if you make it happen, the Amazon bill is going to get you before the errors do.
Yeah. That makes a lot of sense. Now, while these things may initially look all the same, even trivial implementation is very likely to have some divergence and is likely to diverge a lot more over time. For example, with the S3 implementation, you may want to actually have the asset disappear after a certain amount of time, which is easy in S3, but going to require quite a bit more code for the other implementations.
Right. And especially doing it like in the file system or those kind of things. It's like, how do I know how old something actually is?
Yeah.
That can be a much more interesting problem than you think. So the next one, abstracting to deep hierarchies. And this is one that you see bite people a lot when they start doing object-oriented development, because everything's an object and I can inherit a lot. There's other ways of doing this too, right? Like in JavaScript, there's some adapter type patterns that can get the same kind of deal going on. But this occurs essentially when you start visualizing your abstraction as being a set of layers of other abstractions. And like I said, it's most commonly found in OOP based systems, but you can actually do it in any paradigm. It's just harder. You're less likely to screw it up in, like, say, functional. But you could do it with, imperative programming too, just, like old school.
Yeah.
Functions calling functions calling functions.
Yikes. I could, see that. That sounds horrific.
Yeah.
So the real issue happens because as your object hierarchy gets deep, you'll find similar things on different branches that you will be tempted to push down to the least common ancestor in the hierarchy. And that makes sense. I mean, logically, when you're looking at it at the time, it makes sense. However, it may not make sense at that level or in other things that branch from there. So just because these two things are similar doesn't mean that they need to be in all the things that come from that those two things have. Sometimes it's better to have them separate.
Yeah, and that's one of the really weak things with inheritance, by the way, right? Is the ability to create a situation where you have a fragile base class.
Mm-hmm.
You almost really want to build things by composition, not by inheritance, specifically because of that. And this one's harder to explain by example, at least without, really extensive exposition on, the bits and pieces. But one way that you'll notice this is there'll be an excessive number of methods that throw the equivalent of a not implemented exception because those methods are only expected to be used by inheriting types.
Yeah.
Right. So you got the interface, but you can't see that that's going to blow up until runtime.
Yeah. Or if you've got like 5 different classes that inherit from it and you only need it in 2 of those, you're going to have a bunch of those in those things being inherited and in the initial. Yeah. It's like,
yeah. And then when you pass those around and you try to use them in a polymorphic sense, it's, then you get random errors because, it doesn't implement this thing, but that method is there and we try to call it and now it blew up. And so any code that's using it now has to deal with the fact that this is brittle and possibly check a flag and go, hey, is this actually used or is it usable on here?
Take one down, pass it around, 98 inherited classes on the wall.
Yeah.
I couldn't help it, man. You said take it down, pass it around. That just,
yeah.
Where my brain went. Yeah. This sort of abstraction creates excessive overhead for anyone wanting to use the rest of the abstractions in a group, usually a class, by forcing them to implement things that may not be useful for what they're trying to do, or having a not implemented exception thrown, whatever, or by forcing excessive reading of documentation to figure out what base methods are actually usable in this class. So,
yeah. I mean, people always, they harp on the necessity of documentation, and I agree that you should document your stuff. But if you have to read the documentation to be able to use it at all, and you can't reason about it before that, it's, that's a bit of a smell, right? Like you need to be fixing that. So along with deep hierarchies, the other one that occurs is a wide hierarchy. In this case, typically, but not always in OOP type situations, you have a single base type that is inherited from by a large number of other types. And the base provides some really commonly used functionality that's used elsewhere. And by the way, you can do this in other paradigms too. It's just easier to pick on OOP for this.
Yeah, that, I would say it's
because everybody's done this at least once in OOP. I can't say that they've done the same in functional, for instance.
Yeah. I would also say like OOP tends to lend itself to a lot of these issues more. It has other things that, make it good, but then these are some of the pitfalls. So the issue here occurs when one of the objects inheriting from the base needs to inherit from something else as well. In a lot of frameworks, you won't be able to do this. While in others, it's not overly recommended because it adds a lot of extra maintenance issues.
Yeah. Have you done multiple inheritance in C++? You ever done that on purpose to yourself?
No, not.
Yeah, everybody does it once because it turns out that it's not real pleasant if you do it more than that.
Yeah. No, I have thankfully been able to avoid that for the most part. Most of my C++ is academic.
Yeah, mine was too, but that was in, I guess, data structures maybe. But it definitely made an impression.
Yeah. I'm not sure. I'm pretty sure not being like having done so much single inheritance, not like multi inheritance, that I just didn't do it because, well, it wasn't what I was familiar with.
Yeah.
When I took data structures. Got the book around here somewhere. Anyway, sorry.
Yeah. So basically, the deal here is that if you have functionality that's used by a large number of other parts of the system, you need to put it in a class of its own rather than a base class for those other things. This simplifies testing concerns, and it also makes it less likely for a small change to ripple through your code base, right? Because if it's in the base class, people will put stuff in the base and fiddle with it and break potentially other parts of the app. Whereas if it's a contained piece that's just off to the side, they're less likely to do that because it's kind of more obvious that, hey, this affects other things.
This is especially apparent when the functionality in the base class is really more of a cross-cutting concern. Something like logging, caching, instrumentation, that sort of stuff. So the next one we're going to talk about is abstraction for, speaking of cross-cutting concerns. Cross-cutting concerns like logging, caching, or instrumentation sorry, should typically not be addressed in a base class. Rather, they should be handled in a separate class that is usually made available through dependency injection. Putting it in the base class pretty much marries your code to a particular implementation of that.
And the problem that occurs here is that it becomes a lot more difficult to switch out implementations. And additionally, it means that your code is much more tightly coupled to a particular implementation, and that will bleed through the rest of your code base if you're not careful.
Mm-hmm. Yeah. It's one of the things I like about the way that .NET Core is set up with logging.
Yeah, with it kind of being a first-class citizen, and
yeah,
like it's built so that it's understood that it is handled outside of your class, so that you don't have some goober deciding to wrap in log and a bunch of stuff because he thinks it's a file stream. Don't even get me started on that.
Yeah, I've heard that rant more than once. So yeah.
Yeah. This stuff kind of becomes apparent though when a small configuration change in a cross-cutting concern breaks things all over the app. Most parts of your application should really be agnostic to things that like their logging implementation. So when they aren't, it's a sign that something is badly wrong.
Common way to try and deal with this lack of flexibility, if you don't actually want to fix it by using dependency injection, TI for the win, is to add more code to the base class that lets inheritors configure it. He has almost always a terrible idea. I don't know when it wouldn't be a terrible idea, but
it's a real small app.
Will might know. Maybe.
I would say if it's a really, really tiny app, it's not a terrible idea.
I would say it's still a terrible idea because you never know if that app's going to grow.
Right. I mean, like the instant it does grow, you got to fix that first.
Yeah.
But if there's times when it's a quick and dirty one-off and you just get it out of the way.
Yeah, that makes sense.
So speaking of, abstraction with configuration, that's the next smell that kind of comes up. The thing is, when you find yourself in a hole, the first and most important thing that you should do is stop digging. And when you've made a bad abstraction, you should prefer getting rid of the abstraction, to keeping the abstraction and then trying to configure away the problems. The configuration only grows over time.
Oh yeah. I've done that.
Yep.
More than
Everybody
once.
does it. I mean, it's almost like a rite of passage for mid-level devs because they know how to do the abstraction, but it's harder, like until you're at the point where you see where you have over abstracted and you know what that feels like. You think, okay, this is the right way to do it, so I'm going to double down.
Yeah.
And people can double down for a very, very long time on something like this and just, they write code that is really, really hard to parse and follow.
Yeah. A lot of times this happens because a particular abstraction no longer addresses a single area of concern. Instead, it's addressing 2 or 3 or 10 or 20, and not everything needs to be abstracted.
Yeah. Or like here's a great example. Let's say that I've got an entity model class, right? I'm like, hey, like the base class needs to have the ID on it because I do my IDs the same in all my tables, which is probably not ideal either, but we'll leave that alone. And so I'm going to put that there. But these entities also log, right? So I'm going to put logging capability underneath, and they need to be able to raise events when stuff changes. So I'm going to do, the notify property change stuff in there. And, I kind of feel like they also need to be able to create an instance of their DTO, the thing that I kick out on the API. So I'm going to put a method in there to create the DTO from this thing. And, I need to do an equality comparator, and I need to have, get hash code and a copy constructor. And after a while, like that base class gets completely full of stuff. And if you have to add something and you need to do one thing and you try to, extend that base class, you just put like 10 hours of work on yourself for, what really should be 5 lines of code. And, and then the thing is an ecosystem will develop around that, right? Like you'll have all kinds of like repositories and stuff that expect instances of that base type, and they won't function with something else. And it gets really, really hard to untangle if you're not very, very careful about it. And so what you end up doing to fix that is, like especially with cross-cutting functionality, but not necessarily all cross-cutting, just, common functionality, you'll basically inherit instead of compose things. And over time, what you end up doing is you add properties and methods on the base class to say whether a certain thing is supported or not, and extend it and configure it so that things can still act different, but they still use the same interface.
Well, this configuration here is also rather confusing, as it can be very unclear how much needs to be overridden and how much is built in by default.
And how much is correct for your particular use case by default. Because at this point, you'll end up in a situation where you add config and somebody goes, well, by default, we're going to do this thing. Well, they don't update the wiki, right? And so when you have to go look it up, you're going to have to crawl through the code and try to figure out what they're doing. Yeah, it gets to be a pretty huge and nasty burden.
Yeah. All right. So finally, abstraction for swanky syntax. I was really hoping I get to say that one just so I could use that voice. This one's becoming very common, especially with things like fluent interfaces. In essence, you break out an abstraction so that code is pleasing to the eye and expressive. And this is really great when applied properly. This, however, can easily box you in, making changes more difficult than they really should be. I mean, I don't know, I think of this as a big mid-level problem because I used to do this when I was mid-level, where it was like, I would write this like really either super, super highly efficient machine code or this really like cool looking, neat, like check out all like I did all this stuff in one line of code, like so cool coding stuff. And
yeah, the case I've seen it really burn people, at least here lately, has been with fluent interfaces. Where you can chain stuff. With a fluent interface, basically what you're doing is you make a method call on an object, and that method call configures something inside the object and then returns the object, right? So you can chain those calls, and it looks like an English sentence, give or take. And so it's very, very readable, but there's a lot of problems when you do this. And if you haven't really thought out what you're building before you start building it, it's really, really ugly to try to troubleshoot, right? Because you may return a type from that function call, and you may want to restrict what methods are available on it. Well, you're going to have to make another type for that, right? And so you end up with like these weird interface definitions and this stuff that adds a lot of complexity. And by the way, when something in there manages to throw a null reference exception or something, and you just chained it all together on one line of code, a lot of debuggers can't handle that. It's like, yep, it broke somewhere in here. Good luck. And yeah, so it like refactoring to a swanky type of syntax it's very, very pretty. And when it works well, it's very, very nice. The problem is that you really, really have to spend the time to do it right, or you should not do it at all. And common use cases for this is stuff like query builders, object factories, configuration classes, those kind of things.
The thing with these types of abstractions, this is what I've run into, because like for me, it was kind of fluid interface for creating a really complicated search functionality. And I should have broken it down more and then piecemealed it together. But I put it all in this one big, like, just like tacked on, like, dot this, like, and just, it looked really cool, bro. I mean, no joke. It was fancy. But hope the PO really didn't want to add anything else to that search, because yeah. Anyway, it can be really challenging to modify, debug, and test. Oh, debugging. Oh man, I don't even want to, like, that was
like, because you step into it and it's like, you've got some function call and you step in and it's changing internal state on the object. But as that interface gets more complex, a lot of times you're not returning the full interface of the object that you're doing a fluent interface on. You're returning, some subset of it, because there's only certain operations that are valid in a row. Like if you're doing a search query and you're like, hey, do a sort on this field. Well, that function call that does that should return an interface that says, okay, am I done? Or, can I add, more stuff? But it also needs to include ascending or descending. Right. But whatever, if you don't include ascending or descending, the next function call should not have those available on the interface. And so you get this thing where you're implementing like 8 or 9 different interfaces that inherit from each other, so that you can return the same object and you can mess with the same internal state, but you can make the syntactic sugar look nice.
Yeah. No. Doesn't mean it's bad. Like, we've all done it. Like we were saying.
The ones I've written have largely been bad, but yeah.
Yeah. But they can be. And like, I know some of the stuff I've done has been pretty rough. Then other times it's actually solved problems, but used in very, very much moderation. Like not going overboard with it was the big thing there.
Yeah. And really a common problem with this sort of abstraction is that it can be kind of unclear what order methods should be called in, or if the order even matters, and what exactly those methods do versus what they're named, because they can make they make testing with mocks really, really messy. But I've also seen situations where somebody takes one of the methods that does a certain thing, and they're like, well, in my implementation, I needed to do this other thing, and I don't want to debug this, so I'm just going to tack that crap in.
Yeah.
And so you end up with like, you have a lightweight method that's supposed to load your tenant information in your system. Right. And it should be really quick to say, hey, this tenant exists. But people have added a bunch of stuff because some other use case needed it. And so instead of loading the tenant, you're loading all kinds of stats and stuff on it. And it's happening on every web request. Not that I've had any experience with that ever. It's really easy to get there. Good abstractions are required in software development. And I mean, literally required. Like, you are not doing software development without any abstraction at all. Literally none of this stuff would be possible, in fact, without abstractions. We should all strive to create more abstractions that actually work. However, it can be tempting to create abstractions for things that you don't fully understand, things that are likely to change, or to simply create abstractions because it's a better practice. But you really need to rein back that impulse sometimes. An abstraction is like a character in a story. No matter how much you like it, it can ruin the whole thing if it shouldn't be there. Bad abstractions, when left alone, will also often accrete bad code around them, simply as a way to try to fix them or to deal with them. You need to be able to either catch yourself before you write a bad abstraction, or you need to be able to identify the abstraction after the fact and have the will to remove it. That's pretty much all I've got. Beach, what do you have for us this week for tricks of the trade?
So, guys, not everybody understands abstractions. You will work with people, even some developers, who are concrete thinkers and are not able to grasp the concept of abstraction, even though they are using some abstractions. They still see them concretely. And that's actually a way that our brains develop. Like we go through, childhood development. There's like concrete thinking, and then we get to abstract thinking. Usually a little bit before puberty. I think like fifth grade or so, sixth grade is when we start getting that a little bit of abstract thinking in there. Anyway, what's interesting is when you meet people who grasp abstraction in one area, like a developer who understands how to abstract in development, but not in other areas, like their social life or interacting with others or in business. Because these concepts like abstraction applies in these other areas too, but they won't grasp that at all. Like at the beginning of the episode, Will talked about sort of a manufacturing abstraction, like, interchangeable parts. Who was it? Henry Ford came up with that. He didn't invent the car. He just, made it manufacturable. Is that a word? The way I'm using it? Oh, no way. Kind of, sort of, maybe. Yeah. So you'll meet people who like they'll get abstraction in one area, but not in another. On the other side, you're going to meet people who abstract everything. It's like the meme. I haven't seen the all the things meme in a while. I missed the all the things meme. Abstract all the things. And we'll apply it way beyond its usefulness, not just in development, but in every area of their lives. We know a few people who are like that, who try to do that. This is honestly, it's a little bit where like prejudice comes from.
Yeah, it really is. I mean, it's an abstraction that doesn't work.
Yeah. Mm-hmm.
And a lot of times it's developed in people who don't have enough use cases to actually realize that abstraction doesn't work.
Very true. Very true. So guys, just keep that in mind. When you're out there dealing with other people and things like that everyone has their own, like, you understanding or level of understanding of abstraction and how abstractions work. And keep that in mind yourself to make sure you're not over abstracting or under abstracting outside of development too. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.